Okay, in this last video, we're going to talk about negative exponents. So the rule for negative exponents is that if you want to take an exponent that is negative and make it positive, you're going to take the reciprocal of that factor and make that power positive. So if you look at the first example here, x is being raised to the negative 1 power. So what's the reciprocal of x? That would be 1 over x. And when you create that reciprocal, now the power of x is raised to the first. So sometimes a nice way to think about this is to go back to our quotient rule. And let's look at a problem. So let's look at something like x to the fourth over x to the third. The quotient rule tells me I can simplify this by keeping my base of x and subtracting the powers. Numerator minus denominator power, I would get x to the first. Well, what if we had this but in the opposite order? What if we had x to the third divided by x to the fourth? Sorry, this looks very close together. So now I would do the same thing, but I would actually end up with a negative 1. Now, typically, when we first learn about exponent properties, we probably would not have simplified it this way. We would have said, okay, hold on. We have 3 factors of x in the numerator. We have 4 factors of x in the denominator. So I don't really want to subtract from my numerator because I am going to have x factors left in my denominator, not in my numerator. So really, if I simplify this, I'm only going to be left with a factor of 1 in the numerator and a factor of x to the positive 1 power in the denominator, because if I subtract from where my bigger exponent is, I avoid negative exponents. But let's see what we did here. We used the quotient rule the first time through, and we ended up with x to the negative first power. The second time through, we concentrated more on where more of our factors of x were in our fraction. We realized they were in the denominator, not in the numerator. So if we subtracted 4 minus 3, but from the denominator, we'd be left with 1 in the denominator. So these two things here are equivalent. We might not have known the negative exponent rule, but we kind of just proved it by looking at this problem in 2 ways. Now, if you look back up here at the rule, if x is already, let's say, in the denominator of a fraction, you can think about, again, the same idea. If it's a negative exponent, you want to make it positive, you would make the reciprocal of that factor, which would be 1 over x to the positive first power. But now we have something called a complex fraction, which is not always the nicest thing to have to simplify. We're dividing 1 by 1 over x, which if you think back to probably middle school, you would be told when you're dividing by fractions, you keep, change, flip, which would be keep the 1, change the division to multiplication, and flip the 1 over x to x over 1, and you just get 1 times x, which is x. So if you want to avoid this whole middle step, if you're dealing with factors, if you want to make this negative exponent positive, and because it's just a factor of x, now that you know it's in the denominator and it's negative, you can bring it to the numerator and make it positive, which is what our answer does end up becoming, x to the positive 1 over 1. So x came out of the denominator, went into the numerator, and became a positive power. Whereas the first example, x was in the numerator with a negative power. We brought it down to the denominator to make it a positive power. So our goal with negative exponents is to make them positive. So let's try a few of these questions. So for number 1, sorry, I was going to say the directions are missing. So we're going to try to write this expression without negative exponents and without parentheses. We'll try to simplify as much as possible. So this question doesn't have any parentheses, but I have to recognize here that x has a power of negative 2, but 5 does not. 5 has a power of 1. So if I want to make x have a positive power, it's currently, let's just say, write this as a fraction. It's currently in the numerator. So we're going to bring just the factor of x down to the denominator and make that have a positive power of 2. And that's all I need to do for this one. 5 has a positive power of 1, and now x has a positive power of 2 because we brought it from the numerator down to the denominator. Now, the difference with the second question is that I have 2 factors, a negative 2 and an x, both in a parenthesis, both being raised to the negative 1. So if I want to first use the power rule, I could. So the negative 2 is being raised to the negative 1, and the x is being raised to the negative 1. You don't really need the parentheses, but you do with the negative 2, just because it has a negative you have to keep with it. But the x, I don't really need the parenthesis. But what I need to recognize is both of these factors, the negative 2 and the x, are both being raised to this negative 1 power. So to make them positive, I'm going to need to bring both of them down into the denominator and make those powers now positive. So again, I don't need all these parentheses. I just wanted to really stress that everything had to come together. 1 over negative 2x, and now they both have a power of positive 1, so you don't need to write that. And even if you want to bring that negative maybe in the front of the fraction, that's probably where you'll see it. But if you left it in the denominator, that's not wrong. And now this question, similar to the first one, the negative 5 is just being raised to the first. So if I want to make this x to the negative third have a positive third power, I'm going to just bring the factor of x down, make it positive 3, and leave the negative 5. All right, let's try a couple more. Now, this one doesn't actually involve negative exponents, but let's review a fractional power, and then we're going to combine the two, fractional and negative. So in the last video, we talked about radical expressions and how they are equivalent to fractional exponents. So right now I have 7 being raised to the first power, so that's its own power. X is being raised to the 3/2 power. So let's just remind ourselves the numerator is my power, the denominator is my root. So this is 7 times the square root of x to the third. Now, you don't need the 2. Again, if you even look at your choices, 2 of them have cube roots in them and 2 of them have nothing written as the index. Well, that's what we want, because you don't write the 2. Again, if you wrote it, it's fine, but on a multiple choice, you're not going to see it. So the 7 is not part of the radical expression because the 7 did not have the 3/2 as its power. So we should be picking this choice, where only x to the third is under the square root and 7 is out in front. And if you look at the first two choices, they just reversed the power. So they used 2 as the power and 3 as the root. The only way that would be true is if the fraction was reversed. 2/3 would leave you with a power of 2 and a root of 3. Okay, so now we're going to bring these two things together. Negative exponents and fractional exponents. So if I look at something like this question where we have 2x being raised to the negative 4/3, I don't want to apply my understanding of the radical until I get rid of this negative power. So let's think about, we have a 2 being raised to the negative 4/3. We have an x being raised to the negative 4/3. Again, that's my power rule. They were both originally being raised to the first. Now they're both being raised to the negative 4/3 because we multiply powers in this case. Now, I want them to have positive powers, so I'm going to bring them into the denominator. Now, if I don't want to look at them separately, I could have just initially with my original problem just brought the whole thing of the whole factor of 2x down to the denominator and raised it to a positive 4/3 power. That's another option here. I'm just going to keep writing down here. So now I have 4 as my power, and 3 is the denominator, so that's my root. So 2x is being raised to the 4th under a cube root, and it's in the denominator, so I could have made that positive 4/3 instead of keeping it as a negative 4/3, so we should be looking at this choice down here. 1 over the cubed root of 2x to the 4th. And let's just try one more. So if we look at a question like this, 2x to the negative 1/3, we want to remember here that 2 has a power of 1, and it is not included in this negative 1/3 power. So when I want to think about making that power positive, I'm not moving the 2, I'm only bringing that factor of x down to the denominator with a positive 1/3 power, and now I'm going to rewrite that as the cubed root of x to the first, power over root. So 2 over, the cubed root of x to the first. And again, you probably won't see the power of 1 written, so if you look at your choices, this choice would be correct. Okay, I hope this video was helpful to introduce the negative exponent property and to kind of review the fractional power property with negative exponents. You can always rewatch these videos if you want to go over any of these exponent rules.